Good morning, everybody. Thank you very much for joining our webinar on FERRABAIT, which is our new molluscicide, new active ingredient in slug control. My name is David Griffiths. I'm the technical manager for the UK, and I'm very pleased to welcome my colleague Catherine Whaley, who is our product development manager, but heavily involved in molluscicides. She asked me to say it quietly, but been involved in the molluscicide industry for about 20 years, so was actually involved with FERRABAIT pre-ADAMA in the early phases of it. And then very pleased to welcome James Ashton. James is business development manager at Fera, and with previous roles has had about 10 years experience in the molluscicide industry, designing and conducting efficacy trials and advising the industry on slug behavior and control. Okay, so we're going to talk. James is going to start off with just some general information about slugs, their life cycles, breeding, and the complexities of controlling slugs. And we are acutely aware at the moment that it is very dry out there. That there's not a lot going on in terms of field activity in the majority of the country. Slug activity looks low, but James is just going to touch on what that means for slugs, and what happens during these really dry periods, and then what happens when hopefully we do have a little bit of moisture again. And then Catherine's going to run through the technical data that we've got on FERRABAIT and just make sure that everybody is up to speed. So without further ado, I think I will hand over to James.
Super. Morning, everybody, and thank you, David, for the introduction. Yes, as you mentioned, about a decade I've been working on efficacy trials with molluscicides, behavioral studies, as well as registration trials. So firstly, are all slugs the same? What do you see in a field? So there are about 40 different species of slugs present within the UK, and we have snails, but not all of them are major crop pests. Critically, there are different slug species which we know cause more damage to crops or are crop specific. So that first one on the bottom left is Arion hortensis. This is also known as the black garden slug. And is about 1 centimetre when constricted, as it is in that photo. They cause damage to field crops and is a key species used in registration studies. So when you see Arion on the label, we have likely trialled a molluscicide and proven that it works against that species. The next one that has appeared, Arion vulgaris. This is also known as the Spanish slug. This is a really big crop pest in Europe. It was first identified in the UK in 2012, but it's not widespread yet. And that is a really big slug. So that can grow 7 to 15 centimeters in length when fully extended. So that's the length of a small ruler. The next one is Tandonia budapestensis, which is also known as Milax or Milax budapestensis. Now, this species of slug is different to the others on this slide. It spends most of its life cycle under the soil profile. It's a subterranean species mainly, coming up to feed. Now it hollows into the tubers as they are bulking. So again, this is a key slug species that is used in registration studies. So if you have potatoes on a product label, Tandonia budapestensis must have been recorded in that field trial and have been shown to control damage in potatoes. Now, the next one is the big one, Drosera reticulatum. This is also known as the grey field slug, and this is the slug which causes the most damage to field crops. It's highly motile, fast for a slug, and hungry. And I'm sure you've seen those pictures of fields of oilseed rape, wheat that have been completely cleared by slugs, and it is most likely Drosera reticulatum. And this is the slug that we mainly trial in efficacy studies. So do we care? In short, yes, we do care. Depending on which statistic you go for, slug damage can lead from 45 to 100 million pounds worth of lost crop per year in the UK. Now, slugs don't damage all crops in the same way. So there's a picture of oilseed rape on the screen. It will completely take out oilseed rape by eating through the cotyledons, early true leaves, leaving a plant stalk that will not recover. Oilseed rape brassicas are particularly palatable as they have a high content of sugars within the leaves. In winter wheat, it will hollow the grain, so you will have no germination. If it has germinated, they will strip the leaves. Lettuce, brassicas, they consume in a similar way to oilseed rape. Strawberries, they eat the fruit. So in the previous slide, I was talking about registration studies. So for a molluscicide registration, you have to prove that it is effective in the field and also in controlled cages, caged arena studies. This is what a caged arena will look like. So it works to simulate a field scenario. We plant a controlled number of seedlings. So in this trial, it's oilseed rape. There are 50 seedlings, 5 rows of 10 plant stands, and we introduce slugs and pellets and also a shelter refuge, as you can see there, to keep them on the soil surface. So by taking assessments at regular intervals, we can prove that a specific molluscicide bait is able to protect a specific crop, and we can determine the efficacy of crop protection. We're also able to say, by putting a specific species in, that the bait being used does kill that specific species of slug. We usually place 20 slugs into these meter squared arenas, and that is considered to be a moderate pest pressure. And it's not unusual to see by the end of week 1, the picture on the right, which is an untreated control for very few plants to be remaining in the arenas. You can very clearly see from these photos that the molluscicide is having an effective treatment and you are achieving crop protection. But it's dry, we can't see them. Are they still there? So very quickly, the life cycle of a slug. There are eggs, they hatch, they grow into juveniles, they grow into adults, they reproduce sexually or asexually, lay more eggs, and the cycle continues. So this year, summer has been very dry, probably an understatement, dry and warm, and we are not seeing slugs out and about on the soil surface. Microsoft doesn't do slugs, so you've got a snail here, but it's a molluscicide, it will work against slugs and snails. So do we need to worry about control right now? Where are the slugs? Well, they are still there. They have not disappeared. During prolonged dry weather, they will bury down into the soil where it is moist and damp, and they wait for rain, moisture, and as soon as they detect that, they will move back to the soil surface and begin feeding again. So what you, a farmer, a gardener wants is for the first thing that the slug snail encounters is a pellet and not the crop. For winter wheat, you want it to be with the pellet and not with the seed. And it's important, especially when it's been particularly dry, to remember dews. We're not just waiting for rain for slugs to become active again. A heavy dew will produce enough moisture on the soil surface for the slugs to detect and start moving about and feeding again. We also know that when a slug is stressed, it lays eggs, and that a single slug can lay up to 500 eggs. So just because it's dry and they can't be seen, we need to be aware of this possible building population. They are hermaphrodites and do not need to meet another slug in order to lay viable eggs. But the population of slugs does depend on a baseline, and that can be monitored via trapping, as I'm sure you all know. But what is that baseline? So the climate is changing. obviously, we're all experiencing that. Practices are changing, and this has an impact on what we do and what we see in the field. So this year we had a particularly mild winter. So what was typical during winter was freezing temperatures, and the older, weaker slugs would die, and that would knock back the population in the field. This year, 25-26, it was the 8th warmest and 8th wettest winter since records began. And the life cycle of the slug was impacted favourably by that. As long as the climate is favourable, the slug will continue to lay eggs. They will hatch, they will develop into juveniles, the population will grow. So we need to be aware that without a harsh winter, it may be that we have a higher population anyway, and as soon as conditions return to wet, we are likely to see them return as reproduction has continued. Slugs also need food, and more slugs, more food. Well, herbal lays, crop covers, grassland has increased in hectarage through government initiatives, which is good, but it's also favourable to slugs. So now in field margins, we're growing extra food for slugs. We also have a lot more dense coverage and tall lays. This traps moisture. They are cooler and darker, and this is creating the perfect conditions for slugs to remain moist, remain more viable even in this hot temperature, lay eggs, and therefore increase in numbers. And what about eggs in the soil surface? So estimated in 2019 was the most recent statistic I could see. 47.6% of arable land cultivated using minimal till, 7% under no tillage. We also have direct drilling. Now, this does not disturb the soil in the same way. So what we are not doing is breaking up laid egg batches. Traditionally, they were broken up, would end up on the soil surface, they would dry out and die. Direct drilling means this is no longer happening to the same extent, and they will remain in the soil viable, ready to hatch when we get moisture. There are always trade-offs in practices, and I think it could be argued that what we are doing is making conditions more favourable for slugs in fields. So we'll just put a molluscicide down. Surely we can just quickly develop a pellet. I would argue not, and actually it is much more complicated to develop an effective molluscicide than it is a fungicide or insecticide. You need the slug to encounter the pellet. Once it's encountered the pellet, it needs to decide to feed on the pellet. It needs to continue to feed on the pellet. It needs to then ingest a lethal dose, and it has to do this in one meal. The pellet itself needs to remain on the surface, but it needs to be soft enough to consume, but also needs to be hard enough that when it is on the soil surface and in the spreader, it doesn't break down. So it has to absorb water to be palatable, but not become mouldy. We also need it to persist for the reapplication window. We also need our pellet to be the right size that there is enough baiting points for incidental feeding. So they can feed and have one meal. They can feed. It needs to be small enough to have enough active ingredient in it to kill a single slug. So different pellet manufacturers have different ways of achieving this. The base of most pellets is a good quality wheat, a dye, which tends to be blue because it deters birds from feeding on them, an active ingredient, and some other different ingredients. Now, a slug, like a human, doesn't just feed on anything. They have to decide to feed, so it has to be palatable. Before they feed, though, they have to encounter the pellets. Now, this is slightly based on chance, and this is the relevance of baiting points. Now, the baiting points is the number of pellets per metre squared. So we know pellets can be applied at X amount of active ingredient per hectare, and that can be delivered in different ways. So this can be a large number of smaller pellets, so these are the minis, or a smaller number of larger pellets. Now, the greater the number of pellets, the more likely the slug is to encounter a pellet and feed. However, there is a trade-off that you can't just have hundreds of small pellets, as there needs to be a lethal dose of active ingredients for that in that pellet to kill the slug. If the pellet is too small and does not contain enough active ingredient, then it could be argued or shown that the slug will not die by consuming that whole pellet. It then has to move on, encounter another pellet, decide to feed on that pellet, continue to feed and ingest a lethal dose. However, if you make the bait too big and your baiting points are too small, the chance of encountering a pellet is low, and a slug is more likely to feed on a crop or plant along the way. So this is the same reason why with the minis, if your pellet is too small, moving between that first pellet that doesn't kill the slug and the second pellet, it is more likely to encounter plant along the way and cause crop damage. Integrity is critical, as I've mentioned, and there are also different shapes of baits on the market too. So you can get pellets, strands, lentils. However, traditionally we have only 2 active ingredients, and that has been ferric phosphate and metaldehyde. So metaldehyde was banned in the UK in 2022. And something that I've heard a lot in my working life is that ferric just doesn't work as metaldehyde did. They work in very different ways. They have different mode of actions. It's like comparing apples and oranges. They're both foods, but they are different. Metaldehyde worked by damaging mucus secretion cells. It removed the slug's protective coating and effectively dehydrated the slug. And that was why we saw slime trails all over the soil surface. Ferric phosphate works by disrupting the digestive system of the slug, so it makes it feel unwell and feeding stops. So it is a completely different mode of action. And this different mode of action means the slug takes longer to die. So for ferric phosphate, you do not see the dead slugs on the soil surface. When they feel unwell, they are stressed, the same as they are now during hot weather, and they go down into the soil's profile. So they move down where they're comfortable and die there. And that is why we do not see the slugs on the soil surface. And the key there is the slug is alive, yes, but it's not feeding on the crop. Metaldehyde was fast. You could turn up and see the massacre of slugs. So the main difference between the two was that speed of kill. But I think it could be argued that we are less interested in speed of kill as we are with the sublethal effect and the slug stopping feeding. In lab studies, when a slug eats a metaldehyde pellet, you see it physically react to the consumption of the pellet and the metaldehyde starting to paralyze its mouth parts and start to writhe. For ferric phosphate, you don't see this. There is a cumulative effect, but feeding stops earlier than when you first see mortality. So to be honest, doing the studies that we do, it's quite common that although you see an initial speed of kill difference between metaldehyde and ferric phosphate, that crop protection over time does equal out and can be comparable statistically. The key to successful pellet applications and slug control, I would argue, is less about whether you're using an iron-based bait or metaldehyde, but more about knowing your field, knowing your slug population through trapping and making sure you get that initial application of slug pellets down at the right time. We have made it easier for slugs to survive over winter and with modern practices. And I do think when we get moisture, we will see a bounce in slug numbers this autumn when it becomes favourable again. Also, I've spoke about the fact that there has been metaldehyde which is banned, which meant that we've only had one active ingredient on the market for the past few years, which is ferric phosphate. But obviously we're here today to hear about a new active ingredient. So this is the second active ingredient currently registered in the UK in GB, and that is elemental iron, which I know the ADAMA team are keen to talk to you about today. Thank you.
Thank you, James. Just as a bit of a reminder, if you haven't already put your basis number in the chat, please could you do that, and we'll apply for the basis points for you. And if you've got any questions as we're going through, then please also put those in the chat and we'll cover those off at the end. But as James said, ADAMA are very excited to bring a new active ingredient in slug control to the market for autumn 2026. FERRABAIT is the product name. Ferrala is the active ingredient brand name, which, as the previous slide indicated, is elemental iron. So similar, but we'll go through some of the key differences of what makes elemental iron different and better than ferric phosphate. So why is it different? I think the key bit here is the rapid stop feeding and the superior efficacy. Now, James touched on the differences between ferric and metaldehyde, and in the end, ferric has got the ability to catch up in the amount of slugs that it kills. The challenge is that when you've got young, vulnerable crops, particularly with crops such as oilseed rape, that one munch from a slug and that oilseed rape plant is gone. If it's got no leaves, it's not going to recover from that. So getting the kill quickly is what we're missing from the metaldehyde days, and what we're trying to bridge the gap with elemental iron and FERRABAIT. James also touched on palatability. It's important that the pellets are palatable so that the slug gets a lethal dose very, very quickly, and we'll run through that. And then the prolonged pellet life. If it is dry after you've applied or the pressure is lower, then it's important that those pellets remain palatable and in good condition, so that when the slugs do come back, it's still in a condition that is palatable to the slug. And then we've obviously got the other key features that you would expect as standard on a slug pellet. It's got to spread well. You need the baiting point densities and a wide label. And I'm not going to go through every single label crop, but we've got a very wide label. All cereals, all seed rates, all the arable crops are covered. Grass, lays, vegetables, high value broadfield crops. So it's a big, broad label, making it easy to use. Okay, and now just go through some more in-depth information before we go on to the application guidelines. I'm going to hand over to Catherine to run through a bit more about the pellet.
Thanks, David. Morning, everyone. Great to be on the call and get the opportunity to talk to you a little bit about the pellet. Perhaps if we could move on, please, David. Thanks. So basically, my role for today is just to try and talk you through some of the independent trial data that ADAMA have been collating over the last few years to hopefully demonstrate to people like yourselves, to growers, to users, some of these unique properties with this new pellet, why it's a little bit different to what's currently available on the market, and why we feel that it has these unique properties to position it as being a really top quality pellet. I think basically the message I would like to get through to you today is the fact that yes, this is a new active substance. It's registered via HSE. This is not ferric phosphate, but on top of that, it's also quite a complex pellet, and it's made up of different formulation. It's a complex proprietary formulation with over 12 different ingredients. And each one of these is offering something unique to the pellet, which is hopefully then improving the performance of the pellet in terms of how it's working in the field. So yes, we have the Ferrella, the elemental iron, at 1%. And we know that this is, a very, effective molluscicide. On top of that, it's, as with all pellets, it's included with, high quality wheat flours, where we know that, the likes of durum wheat and all of these flours are really there to optimize the pellet palatability for the slug. In addition to this, which other pellets don't have, we have the inclusion of humic acids. And these humic acids basically improve the initial acceptability of the pellet, or you know, how quickly a slug will feed on the pellet. And it will stimulate feeding and it will encourage ingestion. So what we're hoping to do by this is improve in terms of, you know, how quickly the slug will feed, and therefore how quickly the pellet will work. The addition of the humic acid makes the pellet actually black in color, and so therefore, unlike normal ferric phosphate pellets where the dye is incorporated throughout the pellet, we can't do that. So we have to actually get the blue coating as we applied as a coating over the outside of the pellet. And this is then aimed, as with any other pellet, to basically allow people to know when to reapply the pellets and see what's happening on the soil surface. And then also unique to ADAMA is this Desidro technology, which we implement across all our pellets within the range. And this is a unique drying process, which is used by ADAMA. It's a two-stage drying process, and it occurs over a long period of time. And what it basically does is it really improves the integrity and the durability of the pellet. And quite specifically as well, it enables the pellet to have incredibly anti-molding properties. And this can be very important in terms of, you know, the prolonged efficacy of the product in the field, because as soon as a pellet starts to develop mold, a slug is no longer interested in that pellet and it won't feed on that pellet. So you're basically left with just, you know, moldy pellets in the field that are doing nothing. Whereas this, you know, this is allowing the pellet to remain effective for longer within the field. Next slide, please. Thanks. So how do we think Ferrella is working, and, you know, how's this slightly different? So basically the pellets lay inactive on the soil surface. And nothing happens. Therefore, there's no reaction or anything when the pellets are applied on the soil surface. When the slug or the snail ingests the pellet, then this reaction takes place in the stomach of the slug, and this is triggered by the low pH within the slug stomach. And this reaction causes the Ferrella, or the elemental iron, to become what we call bioavailable. So it's basically turned into a solubilized form, and that can be absorbed into the slug. What we are seeing in our preliminary independent lab studies is that this rate of bioavailability with the Ferrella is very rapid, and it means that it's being absorbed really quickly by the slug. And we feel that this is then leading in turn to a rapid, almost stop feeding effect and a quicker knockdown effect within the field. So now, I'm just going to take you through now some independent trial data, which we've generated over the last few years, just to show you some of the other effects or other properties of the pellet that we've been checking in different independent trials. So the first one is basically to show you, or to try and you know, demonstrate this you know, presence of the humic acid, and how basically what we're doing is that we are improving how quickly the pellet is accepted and you know, ingested by the slug when it comes into contact with the pellet. So this was a controlled laboratory trial. It was just conducted in small pots, basically, where one slug was exposed to one pellet, and then this was replicated several times to allow, obviously, for statistical evaluation. Within all our trials, we've obviously compared our product to the two leading market leaders within the UK market. Okay, and what we did here is, all we've done is we've looked for the first 90 minutes when the pellet is applied, how quickly the slug, once it came into contact with the pellet, would feed on the pellet. And what we've found, obviously, is within that first 90 minutes of the pellet being applied, 70% of the slugs fed on FERRABAIT, and this was compared to 30 and 40% with the leading market leaders. So what we're showing is just immediately after application, we're getting high numbers of slugs feeding instantly on the pellet. So then we're wondering, well, if that's the case, then what would this translate to in terms of field data? So here we have data from these simulated field caged arenas, which James was mentioning before. So 1 meter by 1 meter contained plots, where you can standardize basically your crops. You can standardize the planting density, the growth stage of the crop. You can introduce a specific slug species at a standard pest population. And then what you can do is you can go back at regular intervals and you can see what this means in terms of what we're seeing in terms of what's happening to the slug and what's happening to the crop. Within a field situation, this is very difficult to evaluate because, as we've already mentioned, that slugs will move and they'll hide in cracks and crevices in the soil surface, so it's impossible to see what's happening to the slugs. You also don't have obviously a standardized pest pressure across a field situation, so you may get variations across plots in a field based on what you're seeing in terms of the slug activity. So here what we can do is we can slightly compact the soil and we can put in a refuge, and this will allow us to monitor a little bit closely what's happening with the slugs and also see exactly what's happening in terms of how they're feeding on the crop. This crop in here was actually a brassica crop, so highly palatable to the slug. The slugs that we used in this trial were the field slug, Dorossus reticulatum, and all the pellets that we trialed in this trial were applied at a standard rate of 7 kilos per hectare. Now the chart on the left-hand side is basically showing the numbers of dead slugs that we were recording in these plots over that trial period. So you can see, a characteristic 3 to 4 day delay before you start to see the mortality coming through with the ferric phosphate, which is, very typical of what you would see with this active. What we are seeing with the FERRABAIT is we can see this faster knockdown where you can begin to see, slugs becoming severely affected and moribund and, dying within 48 hours after application. And what would that translate to in terms of what people would see on feeding damage of the crop? Well, if you look at the chart on the right-hand side, then yes, every pellet is offering crop protection. Every pellet is protecting the crop to some extent. And you can see the high level of feeding damage only 3 days after, pellet application within the untreated plots. But what we are seeing is we're seeing that higher level of crop protection earlier on in the trial through this faster activity with the FERRABAIT pellet. Then we started to think about prolonged pellet efficacy. And as I've already mentioned, what we want a pellet that can be applied when it's wet, when the slugs are active, but will retain its integrity, will be highly durable, and will be not developing mold quickly in the field, because once we've got this mold, then we've got basically a redundant pellet. So this was a trial that we set up looking at some basically artificial weathering onto pellets. So we had pellets that were positioned on topsoil within large, great big arenas, and then we applied a simulated rainfall over these pellets. And the simulated rainfall was the equivalent of 4 millimeters of simulated rainfall per day applied for 10 days. So, rain every single day for 10 days. You've got three photos here, three images. So we've got the two leading competitors, then we've got FERRABAIT. The pellet within each image on the left-hand side is freshly applied pellet. So that's what you would expect the pellet to look like as soon as it's being applied in the field. And the image on the right-hand side is after the pellet has undergone, the 10 days of weathering. So you can see basically in all instances, the competitor products have developed mold over that period of time, and the slugs will no longer feed on that pellet. But what we are seeing, which we believe is accountable due to this desidro technology, is the very strong anti-molding properties associated with the ADAMA pellet, meaning that 10 days after application, you've still got that pellet. If it's not being fed on by a slug, it's still it's intact and it's effective within the field. So obviously we presented this data at some meetings, and then it was obviously not 2026, and the fact that you know, people were saying, well, hang on, you know, 4 millimeters rainfall isn't very much in the UK at this moment in time. And so what happens if you increase the irrigation and put it under, you know, a little bit more of a robust test? So we repeated this exact same trial, and we applied it at 10 millimeters rainfall and then 15 millimeters rainfall. Now, instead of images here, I've just presented the data as charts. So these charts are basically showing the integrity of the pellet, and this is assessed every day during this irrigation process. And the pellets are assessed using a scale of 1 to 10. It's a very basic, but there's very strict categories within each numbering. So 1 is basically saying that your pellet is unchanged. It looks like a freshly applied pellet. It's, you know, it's very robust and you know, intact in shape. And then you go right the way across the whole scale to number 10, where basically the pellets have disappeared. They've just completely disintegrated. And within that range, there's all different types of categories to show, you know, whether you've got, you know, the pellets are becoming deformed, whether they're absorbing and taking on moisture and then turning into a pulp and things like this. But basically what we're seeing is within both instances, we're still seeing this exceptional integrity with the FERRABAIT pellet. And that is across both the 10 and the 15 millimeters of simulated rainfall. So even under, you know, prolonged heavy rainfall, the FERRABAIT pellet is still, you know, showing high durability in the field. Next slide, please.
Has just moved on, hopefully, as here.
Okay. And then what we're also looking at here is we're looking at the development of moulding. So within this exact same trial, whilst we're also looking and recording pellet integrity, we're also looking at whether the pellets are developing mould within that same test. And we can see around about what day 7, day 8, you can see that there's very strong moulding starting to develop with the competitor products. And then again, you can see with the FERRABAIT product, incredibly strong anti-moulding properties. So we're basically saying here that, you know, the retention of the efficacy in the field is very strong. We can put down a pellet and it may not be fed upon instantly, and that doesn't matter. That doesn't matter because it can withstand the rain, it can, excuse me, keep its shape, it can, you know, not develop mould, and it can then work as required later on in the day. Okay, thanks. So the next part that, you know, I know James has also touched on is this importance of baiting point density. You know, ADAMA have put a lot of work into making sure that we feel that we've optimized this in terms of a trade-off between, you know, the size of the pellet and the effect that we're seeing. Excuse me. So basically, you know, as we've already discussed, there's benefits of a large pellet, because with a large pellet, you've got sufficient pellet that the slug will easily be able to ingest a lethal dose within that one pellet. And then you've got the mini pellets, which you know, are exceptionally good in terms of, you know, offering a huge number of pellets for the slugs to encounter in the field, you know, when you've got large pest pressures, but they may not always spread as accurately. Some have reported that they may break down more easily in wet weather. And we've also got a trade-off of basically, you know, is one pellet going to be sufficient to kill that slug in that field? Sorry, next slide, thanks. So what we have here is we have some data that were generated again by an independent lab. And what we've done here is we've tried to estimate exactly how much pellet is needed to kill one slug in the field. So we've looked at both juveniles and adults. As you know, juveniles might be smaller, you know, might be smaller, but they're very voracious in their feeding. You know, the newly hatched juveniles can cause a lot of damage. and they're very hungry and they're very mobile. And then you've got the adult slugs. And what we did is we separated juvenile and adult just based on the weight. Okay, so juvenile was around about 200 milligrams in weight. Adults were around about 400. We've got four charts here, sorry. Sorry. On the top level, on the juvenile slugs, on the left-hand side, we have a chart here. And this is showing basically FERRABAIT compared to the market leaders of round about a similar sized pellet. And what we're seeing here is, whilst less than one pellet was required to kill the juvenile slugs in all instances, considerably less pellet was needed with FERRABAIT compared to the other two pellets. And then on the right-hand side, it's the exact same trial, but with the market leading mini pellet. And interestingly, what we're seeing here is the fact that with that mini pellet, that slug, even though it's a juvenile and it's only 200 milligrams in weight, it still has to find that second pellet in order to induce a lethal dose, or ingest a lethal dose, sorry. So you're adding some sort of something into the equation whereby the slug has to ingest the entire first pellet and then stop and then move and then find that second pellet and continue feeding without it bumping into a plant, without it feeding or sample feeding as it goes on the crop. So that is an important thing to take into consideration, I think, when you're evaluating the performance of a pellet. Then we move on to the adult slugs. So those are the two charts listed below. So on the left-hand side, we've got the pellets of the similar size, so similar baiting point densities. And what we can see here is actually that, again, more than one pellet, or just about one pellet for that one of the competitor products, was needed to induce mortality, whereas less than a single pellet was needed with FERRABAIT. So again, that slug only needs to find that one pellet with FERRABAIT and feed and take in a lethal dose for it to have that affected. We've removed the parameter that has to find that second pellet. And then with the minis on the right-hand side, again, you can see that it's needing about 1.3 pellets of a mini pellet to induce mortality, compared to around about 60% of a FERRABAIT pellet. And then I think that's all the data that I needed to share with the guys today. So I think that's over to you now, David, on directions of use.
Yeah. Okay. Thank you very much, Catherine. And please, any questions, please do ask them or put them in the chat, and we'll try and cover everything off. So in terms of application guidelines, I mean, you've seen a few bits about the rate that we've been using in the trials there. The maximum individual dose is actually 8 kilos as compared to 7 kilos in ferric phosphate. But with the work that we've been doing with field rates, we're looking at the equivalent 5 kilos to 5 kilos. So if you've been using 5 kilos of ferric, then 5 kilos of FERRABAIT is going to lift the performance from what you were seeing with ferric phosphate. And in terms of the other general application guidelines, there isn't really anything different from what you'd see with ferric phosphate. So applying as a broadcast treatment as soon as you're seeing damage, or as you're seeing by test baiting. For some crops, particularly those such as oilseed rape, where one bite from a slug and taking off those cotyledons renders that plant useless, then you can apply it at drilling. And then application timing should be based on the likely pest pressure that you've got, and the crop that you've got, and repeat, obviously, if repeat applications if the pest pressure remains high. Minimum application interval is 5 days. Application method by hand or by mechanical applicator, and I'll touch on the different applicators in just a sec. I mentioned that 5 kilos of FERRABAIT is equivalent to the 5 kilos of ferric phosphate, and this is just to give you a bit of information on baiting point. As Catherine has touched on, we're a midi-sized pellet, So 5 kilos is giving you 42 baiting points. Should you wish to increase that to 7 kilos, then that's giving you 59 baiting points per square metre. And for those really high value crops, such as veg crops, lettuce, etc., then you have got the ability, should you need to increase it up to 8 kilos. We're pleased with FERRABAIT that we've got an application tool for you to be able to use. I'll touch on which spreaders are on there in just a sec. This is a web-based tool. It's a FERRABAIT spreader guide. It's really, really simple to use. You're essentially going in there and you'll see in the pictures left to right that you choose the spreader that you've got. You choose the width that you're wanting to spread at. In terms of spreading width, out of single disc applicators, we're happy with an 18 metre spread width. With a twin disc applicator, which there are a few on the market, we're happy with a 24 metre spread width. So you choose your spread width, you then choose which rate you'd like, and then the guide gives you the application settings that you need, and that, depending on the forward speed that you want, and that it tells you then the different flute settings. And that's just a slightly bigger version so that you can see it. And if you want to download the PDF on the web-based one, then you can download that and attach it onto your recommendation sheets. There is a slide missing there, actually. I'm not quite sure where that one's gone, but just in terms of I'll make sure I think you've got it actually, Tim, in your slides, but I'll make sure that we've got it when we send them across. But there are, I think it's 7 different applicators that we've got tested for the label. As soon as you've got more than 2 applicators tested, you then don't have any restrictions on the label as to which applicators you can use. So you can use any applicator you wish, but we've got those 7 applicators on the FERRABAIT spreader guide. Like I say, single disc happy up to 18 meters, twin disc okay up to 24 meters. And then just in terms of a summary of what we've talked about with FERRABAIT, it is a really complex formulation, 12 different active ingredients, designed to make the pellets really, really palatable, so that we're seeing quicker speed of kill and that quicker stop feeding effect that we're seeing with it. And that's down to the 2 main factors. One, it's very palatable. They're getting it into the slug very, very quickly, and then once it's in there, the initial results show that it's working quicker in the slug stomach than what you get from ferric phosphate. And then really importantly for use in the field, and the conditions that we get right at the moment, hopefully we'll get a bit of moisture, but it's this robust integrity, and making sure that the pellets remain palatable and mold free and effective for longer. So if the pest pressure is a bit lower initially, they're still there 10-14 days later when you need them. So I hope you've got what you need out of this presentation. We're very excited about it. A new generation in molluscicides, a new active ingredient for slug control, which is much, much needed, and lifting the performance over what we see from ferric phosphate. Has anybody got any questions? Any of us? Silence in the ranks, Tim.
Indeed, it is, yes. Any questions from anyone? Doesn't look like it.
Okay.
Nothing seems to be coming forth.
Okay. Hopefully that means because we've covered everything, we haven't sent them to sleep.
Absolutely. Yes, hopefully that is the case. Thank you very much for the presentations this morning. Enlightening in terms of all the aspects that you've covered today. So thank you for that. And I hope the